Today I will design a single phase full wave rectifier with filter and without filter. Today we will open a PROTEUS design software. We see the place, we see the window in previous video, same window as today see, and we see the top of the web, another function. Today we will collect a component. We select P, then we collect firstly pick up a transformer. Today I will use ideal transformer in this project or in this simulation. Then we click OK. Then again we will pick up diode. We click generic diode and OK, and then we click P again and we pick up resistor. Then click OK. Then we place the component in the board to complete the connection. Firstly we place a transformer, then we place diode. Basically full wave rectifier we use 4 diode, we know in the theory, so we place 4 diode and we can flip. We click rotate clockwise and we can wiring the 4 diode each other. In wiring we use mouse left click and place a resistor and we rotate clockwise. Then we completed the connection by diode outside and the resistor, and we connected transformer one side in one diode and second side opposite diode. We need a ground, so we connected the ground in transformer. Next we need a voltage source, and we know transformer is working in AC voltage, so we need AC voltage source, and we connected AC voltage source in the transformer. And we need AC voltmeter because it is AC source, so we need AC voltmeter. One AC voltmeter parallelly connected in the input of transformer and output of transformer, and 1 voltmeter is output of the in parallel to the resistor. After completing the wiring, we input oscilloscope. We know how to oscilloscope input, and we connecting the signal source and voltmeter by transformer, and input sine wave. This is signal, sine wave signal we connected in the circuit, and output outside voltage with voltmeter connected with the across resistor, and signal input we connected oscilloscope A port, and output of transformer connected in the oscilloscope B port, and rectified current output diode of connected in the oscilloscope C port. Basically C port is measure how the rectifier current in rectified the current by diode, and we see the oscilloscope output, and we change the transformer ratio. We know transformer consists of primary and secondary. We change the value of transformer primary and secondary value. If we want to show the value in our simulation diagram, so we click show all and then click OK. We show in the value, and we cannot change the diode value, and we change we know RMS value of transformer. Change RMS value 20 volt, and we know AC frequency 50 Hz. We change 50 Hz and then click OK. This is our without filter circuit. We complete our without filter circuit of and rectifying current, and we see the oscilloscope, and we see in F is original sine wave, and B channel A yellow and B blue is basically output of transformer current, and C is our main pink color or red color is our main rectifying current, that output rectified current by diode. We change the knob setting. We can shift or changing value of sine wave, cos wave. In channel A port, we see connected in the input of transformer that's are connected in the AC signal input, and we also the original input channel A, and channel B connected in the output side of transformer, and we see the oscilloscope. Channel B is blue color, and if we change the knob, then we change setting and also change shape, and we output in C is basically output of the rectified current. Rectify basically DC AC current to convert to DC, so we use C basically output of rectify current. And if we click cursor, then we see the value of input graph of sine wave shape graph out value. We see the value if we click cursor. If we want to need value, so we click cursor and then measure the value of graph. And in this circuit, we need with simulation on, we see the voltmeter, AC voltmeter change in this display. We need a capacitor to filter the circuit, so we pick up a component mode and pick up a capacitor for this circuit if we want to filter the circuit. We searching a capacitor and pick up a capacitor and place the capacitor in the circuit and complete the connection. And then we change the capacitor value 10 microfarad. After complete the circuit, we run the simulation, and we see the changing voltmeter output. The circuit only works. And we click debug and oscilloscope. We see the oscilloscope output. We know how the rectify. Basically, it's not full rectified signal because of capacitor value is minimum, so poor, so we cannot rectify the fully. Some side portion we rectify the current. We see DC is not fully DC current, but it's something portion with DC will measure in. If we increase the capacitor value, we see the DC is properly accurately. And blue, basically pink shape is the our output, main output. And yellow is our main input signal, and blue is the output of transformer side, and C is our main filter with DC current. This DC current not properly DC, pure DC, because of capacitor value is very small. If we increase the capacitor value, we see the DC portion is higher accurate to the DC. Basically, rectifier signal is convert AC to DC signal, we know in the theory. So this is our simulation. We solve this problem in our simulation PROTEUS software. How can we design, or how can we DC? Thank you everyone to see this video, and next we'll show proper design, another type of design, and we discuss about U, and we can change the shape. Thank you everyone.